Dear learners, today we will discuss about ideal gas equation. In previous session, we have seen about gas laws, which state the relationship among fundamental properties of the gas. The four fundamental properties, pressure, temperature, volume and quantity, are interrelated and expressed mathematically, giving you gas laws. But at the same time, the relationship among all the fundamental properties of the gases gives you ideal gas equation. In case of empirical gas law, we have seen that there are relationship between two properties, whereas two properties are kept constant. But when we are dealing with all the fundamental properties simultaneously, then what kind of relationship that may generate gives you ideal gas equation. Before dealing with ideal gas equation, let's remember gas laws again. We have seen four gas laws: Boyle's law, Charles' law, Gay-Lussac's law and Avogadro's law. On your display, you are having summary of these four laws. What are the two relating properties? Which are the two properties that are kept constant? And what kind of expression that particular law generates? Considering all these four laws, now we will move forward toward the ideal gas equation. Let's see, in case of ideal gas equation, you are working with or you are dealing with all the four properties. On your display, you are having pressure as the fundamental property, you are having temperature, you are having mass, that is your quantity, and now the fourth property is your volume. So how the pressure will deal with volume or how temperature will deal with volume, the interrelationship between pressure and temperature, how mass and volume are related with one another, that we have seen in case of gas laws. But in case of ideal gas law, the ideal gas law states that the volume of given amount of gas is directly proportional to number of moles of gas. Which law? Remember, which gas law deals with volume and quantity? Correct, Avogadro's law. So, considering the relationship between the amount of gas and mole of gas and its absolute temperature and inversely proportional to the pressure, means the volume of fixed mass of gas is directly proportional to quantity and temperature, whereas it is inversely proportional to the pressure. So, stating the mathematical expression, you will have volume is inversely proportional to the pressure, whereas it is directly proportional to quantity and absolute temperature. Solving this relationship mathematically, you will have one constant that is known as R, gas constant, and you will have equation as volume is equal to gas constant multiplied by quantity multiplied by temperature and divided by pressure. Simplifying this, you will have equation PV is equal to nRT, where P stands for pressure, V stands for volume, N stands for quantity of gas, R stands for gas constant, and T is your absolute temperature. This equation is called as ideal gas equation. So the gases that obeys ideal gas equation are known as ideal gases. We have seen in case of solutions. The solutions which obeys Raoult's law are known as ideal solutions and which shows deviation are known as real solutions. Similarly, the gases which obeys ideal gas equation means the gases which are having interrelationship, simultaneous relationship between all the four properties is your ideal gas, and the one which shows deviation from ideal gas equation, that is your real gases. Now that is quite clear that real gases won't obey ideal gas equation, means they shows deviation. So it is important to understand how they get deviated from your ideal behavior. So the extent to which real gases departs from its ideal behavior is given by the terminology known as compressibility factor, that is your Z, given by equation Z is equal to PV upon RT, where Z is your compressibility factor, P is pressure, V is volume, R is the gas constant and T is the absolute temperature. It is assumed that For ideal gases, Z is equal to 1. Therefore, you can easily say that as real gases won't shows ideality with gas equation, means it won't has Z value equal to 1. Thereby, you can say that your real gases has Z value being less or greater than 1. But one scientist known as Wonderwalls who says that you can apply the ideal gas equation to the real gases as well. But for that you need to correct pressure and volume. As you are saying that your real gases won't shows ideal behavior. Means the four fundamental properties are not related to one another simultaneously. But Wonderwall says that you can change this equation to the equation which has been ideality with your real gases by changing pressure and volume. According to Van der Waal, the molecule in gas possess no volume and thereby they are not having any kind of intermolecular attraction. As they won't possess volume, as they won't have intermolecular attraction, hereby you can say that you need to correct the effect of pressure and you need to correct effect of pressure and temperature on volume as well. So according to Van der Waal, after correcting pressure and after correcting the volume and the ideal gas equation that will suit to real gas will become P plus an square upon V square into bracket V minus NB. Here the ideal gas equation PV is equal to nRT is corrected by changing your pressure and by correcting volume. The left hand side is corrected whereas right hand side is as such like your ideal gas equation. So this equation will give you Van der Waals equation. Now you need to study the basic difference between ideal gas and real gas. What is actual difference between ideal gas and real gas? Let's see one by one. When it comes about the laws, all the gas laws, then the basic difference between ideal gas and real gas is what? All the gas laws are obeyed by ideal gases irrespective of temperature and pressure, whereas real gases can only obey gas laws at low pressure and high temperature. The next difference based on the same gas laws is ideal gases obeys ideal gas equation, whereas real gas shows deviation from ideal gas equation. Now when it comes about the volume and effect of temperature and pressure and on the volume, then ideal gases occupies negligible volume as compared to total volume. If you are having X volume of container, the container which is having capacity of X volume, then you can say that the volume occupied by ideal gas is X minus B. Means very negligible volume has been occupied by ideal gases and it has been assumed that maximum amount of gases deviates from ideal gas equation. Thereby they occupies a maximum volume. That's why ideal gases occupies negligible volume whereas the maximum volume has been occupied by real gases. The next difference as per the statement of Van der Waal is there is no intermolecular force of attraction between ideal gases whereas the real gases has some kind of intermolecular force of attraction, thus making ideal gases with the elastic collision whereas real gases has non-elastic collision. This was about the difference between ideal gas and real gas. Thank you.